Bismillahirrahmanirrahim. So today we will discuss more about the RLC circuit, and I think inshallah we can finish the DC analysis by today, and next inshallah tomorrow inshallah we will start the AC analysis inshallah. So we will discussion on RLC circuit. So yesterday I have told you if you have a LC circuit, then you will get the oscillation, right? I have already told you if you have a LC circuit, we will get, yes. So we will see from some different cases, that means how the current and the voltage pulses will be looking like in a RLC circuit for the input. For example, you have a RLC circuit which is having a resistor, inductor, and a capacitor, and suppose you charge the capacitor by using a switch. At time t equal to 0, you open it using something, let's say this is some RS, and by using some source Vs or V0 you can say. So the initial voltage across the capacitor will be at time t equal to 0 plus
V0.
Yes, at time t equal to 0 minus the voltage across the capacitor Vc of t. This means Vc of 0 minus will be equal to V0. So Vc of 0 plus also will be equal to V0. I think so. At t equal to 0 plus, we can draw the circuit as follows. You have just an RLC circuit. Assume that you have a pure inductor, a pure resistor, and a capacitor with initial voltage, as I told you, right? So initially the current will try to flow from the capacitor like this. It is IC of t. So you can have a current like this, and you have an initial voltage. So what will happen to the initial voltage? Can you tell me? The voltage across the capacitor Vc of t
decrease.
Yes, it will be transferring energy to the inductor, and inductor also will transfer energy back to the capacitor, but there is a resistor in the circuit and it will eat the energy or it will absorb the energy. So you will get something like an oscillation which will be exponentially decaying oscillation. You will be getting this, maybe initial voltage is V0. Let's say it will be decaying like this. I hope it is clear to you, right?
Excuse me, doctor.
Yes.
The inductor also have some energy. It's because if you
There is
open
no
the
energy for the inductor.
there will be current. There will be initial current. Am I right?
Yes, there were, okay, in this case actually, okay, I will include it, sorry, because the switch was like this. This is closing at t equal to 0. Okay, I think this is clear to you, right?
Okay, that's clear, doctor.
Yeah, thank you for it. Okay, I didn't notice it actually. So you can see here the current will be flowing as shown, or the voltage across the capacitor will be decaying, and finally it will be going to 0. And I think you understood. Yes.
Why it's decaying sinusoidally instead of exponentially?
I have told you yesterday in the lecture.
Tank circuit, يا معاذ.
I have already
yes,
told you yesterday. You remember yesterday LC oscillations. We have told you. We have discussed.
Yes.
I think almost 45 minutes we have discussed about it. LC oscillations. Okay.
Yes, I remember.
Yes, but there is a resistor in the circuit. Whenever there is a resistor, there will be a decay. If there is no resistor, the oscillation will be there for till infinity, as long as when time tends to infinity.
Ideally, there is no loss in energy. What?
Yes.
Yes.
The
Yes,
inductor
the
current will
resistor
start
will
from 0, right?
absorb the energy. Inductor current will start from 0. So the inductor current I didn't draw actually. I will show you, inshallah. Okay. So for this case, I will show the inductor current. The inductor current means that is the actual current in the circuit, right? Like this I of t.
Yes, sir.
Yes.
Yes.
So you can measure the current in two different ways. You can see this is anti-clockwise. So if you give the positive sign to anti-clockwise, then you have to give negative sign to clockwise. It is up to you. You understood? The way in which you are connecting an ammeter. So here for anti-clockwise, I can give positive or negative. What is your choice? I will give according to that. Okay.
Positive, negative.
Positive.
Okay, positive. Okay. So the current will be going to positive like this. So it will be like this exponentially. The current will also decay like this as shown. You can see it will be going like this. It will be decaying. I hope it is clear. This will be the waveform. Okay.
Yes.
This is I of t. Okay. So,
Yes, sir.
but you cannot expect the oscillation always. You cannot expect the oscillation always. It will depend upon the value of R, L, and C. There will be yes. Who has? Okay.
Doctor, is this
Is it audible?
the current decaying in the inductor?
The current decaying throughout the circuit. Throughout the circuit, you can see the voltage is decaying. So the current also will decay. Inductor current will be equal to the current in the circuit because everything is in series. So all the current will be same. Inductor current will be equal to, yes, you have to notice it. Inductor current will be equal to resistor current. Everything IC of t, that will be equal to I of,
Yes.
we can say. All the currents will be same. Only the voltages will be different. Inductor voltage will be different. You know how to find the inductor voltage, L into di by dt. So if you know the differential, if you take the differential, then you can find the inductor voltage. Inductor voltage will be, you can see it will be cosinusoidal. You can see this is sine, the other will be cosine if you take the differential of that. So anyway, you cannot always expect the oscillation. That is the main thing. The oscillation sometimes will not exist because of the value of R, L, and C. The value of R, L, and C actually they play an important role. Actually, they play an important role in making the oscillation. Okay, so the values of R, L, and C actually they play an important role in making oscillation. You cannot say there will be oscillation. If there is no R, definitely there will be oscillation. If R equal to 0, oscillation will exist for sure. It will be sure. Inshallah, it will be sure. Okay. But if there is R, L, and C, according to the value of R, L, and C, sometimes there will be oscillation, sometimes there will not be oscillation. You can view it in different way. I will tell you, I will just draw the value of the voltage. Vc of t in the case of oscillation, suppose if there is oscillation, then if there is oscillation, it will be like this. If there is no oscillation, sometimes the current will decay somewhat like exponentially also. It will be like this. It will also go like this. It is not exactly exponentially. Sometimes it will be taking a curve of hyperbolic sine. You know hyperbolic sine? Sine h.
Yes.
Have you heard about it? Inshallah, we will prove it, inshallah. Okay. So it may take that kind of shape also sometimes. Okay, sometimes it will go like this, sorry. Sometimes it will go like this also. Okay, so this kind of behavior can also expect according to the value of R, L, and C. But if there is no R, definitely you will get oscillation. If R equal to 0, I will draw if R equal to 0. If R equal to 0, definitely you will get the oscillation. You will get the oscillation like this. Sorry, it will be going the same way like this. This is the case when R equal to 0. Okay, I hope it is clear to you. Mathematical things,
Doctor,
inshallah.
excuse me.
Yes.
Here, when R equal to 0, but L and C is in different value. It's gonna be
No,
a
there is no
sinusoidal
issue.
wave, regular like this, or be a different shape.
No, it will be sinusoidal wave. Okay, it will be sinusoidal wave. We can prove it mathematically anyway. The shape of the wave can be proved by using differential equations. Okay.
Yes,
So similarly for the current waveform also will take the shape. Sometimes it will be oscillation. You can see here the current waveform is oscillating. This one I am talking about. But sometimes it will go like this also. Like this. It will also go like this sometimes according to the value of R and C. So R, L, and C will play an important role here. Now we will see another RC circuit. RLC circuit. Okay, so this is the example 1. Next we will see example 2, another RLC circuit.
Doctor, this is
which
source free, right?
yes, it is source free, we can say. You know, we are removing the source at time t equal to 0. This is source free. Source free.
Yes.
Now we will see RLC circuit example with source. Okay, with source. So how it will be looking like? With source means you will give a DC voltage, maybe U of t, you can say, maybe U of t or V0 into U of t, some voltage into U of t. That means you are closing the switch at time t equal to 0. That is the meaning, right? U of t means what? You are closing the switch at time t equal to 0. Yes. So we have an R, L, and is something known as C. Okay. So this kind of circuit will have some other kind of behavior. What is the initial voltage across the capacitor? Can you tell me? The voltage across the capacitor, VC of 0 minus was 0 volt, right?
0 volt.
Yes. Now we will talk about the
0 minus.
and the 0 minus I'm talking is 0 volt. So VC of 0 plus is also 0 volt.
Yes.
And I'm talking about the current. The current across. So the current. Now what will be infinity? What is VC of infinity? Can you tell me what is VC of infinity? Up to what voltage it will go?
V naught, so.
V0.
Yes, we are talking about V naught. Okay, that's U of t. That's what V of t into V naught. So it will go to V naught. So the final value it is going is V naught. Okay. And I told you this is an RLC circuit. Definitely you can expect the oscillations. Mathematically, inshallah, we will prove it. So what will happen when you switch on initially? If there is oscillation, then it will be going like this, going down, going like this, and finally it will go to the voltage V naught. Okay, this graph, I think it is clear to you. It is going above V naught. You see here, it is going above V naught because of the sudden change in the voltage. Because of the sudden change here, you can see there is a sudden change. If you differentiate the step function, what you will get?
You will get constant impulse.
For t greater than 0, this is a constant. So it will be 0 here. But what will be at the situation at t equal to 0? There is a sudden change, right? There is a sudden change. Yes, it is an impulse. An impulse is having amplitude infinity. You know that thing, right? because of this guy, because of this impulse, or that's because of the sudden rate of change, or we can say there is a rate of change. The rate of change is very high at t equal to 0. Rate of change, because of this rate of change at t equal to 0, you may get some overshoot here. We call this as the overshoot. It is overshoot. It is going above the actual value. And you will study this response, inshallah, in automatic control, inshallah. Okay, you can see the second order system response in automatic control. So this is the overshoot. But in some cases, I told you, there will not be oscillation. So this kind of system with overshoot, we will call this system is known as underdamped system. Underdamped means what? Damping, you know what is damping?
Oscillation.
Damping means, no, it is not oscillation. You know what is damper? Damper means, on the door we fit something like this.
Yes, sir,
You know,
we know them.
yes. On the door you can see, to move, to restrict the movement, we fit something on the door. In offices and in maktab, sometimes we will be using this thing. In masjids, you might have seen this, right?
مثبت.
Yes,
Yeah,
Yes,
what
sir.
you, yes, that is the damper. We will call
Yes,
in
yes.
English it is damper. Okay, damper means it will try to prevent something. It will not allow the door to move freely. You understood?
Yes.
Yes.
So, but here you see this is moving. Here there is oscillation. That means it is moving freely. So there is no damping, or damping is below some level or less than 1. We will say this is known as damping coefficient, lambda, which is less than 1 in mathematically. Inshallah, we will see the significance of this. So this is known as underdamped system. And there is another system which is known as critically damped. The response will be, there will not be oscillation, but it will be going very fast. And you can see this like this. Understood? And in this case, we call delta equal to 1. This is known as actually critically damped system.
Doctor, this is called also
damped
zeta, right?
Yes, zeta also. You can see in some textbook, we will use like this zeta, right? You can see in some textbook. Or
Yes, right.
in some textbook, we will use delta. I think you have studied automatic control, I think so, right?
Yes.
We
This
will
semester.
see that.
Yes.
This
But there are some system, in some cases, it will be going very slowly and it will take some lot of time and it will go to V0. And this system is having delta greater than 1. And this is known as overdamped.
undamped.
This is overdamped. So the previous one first was underdamped. This is delta equal to 1 means it is critically damped. Delta greater than 1 means overdamped. So these kind of responses, the value of delta will change according to the value of R, L, and C. Okay. So it is depending upon the value of R, L, and C. I hope this is clear to you, right?
Doctor, we have
Yes.
also overdamped, right?
Yes, I have already explained overdamped. This is overdamped, you see, overdamped. Overdamped means the delta is greater than 1. That means your damping is very high. So what will happen if you have a door?
No. I mean, Doctor, undamped. Undamped.
Undamped, actually underdamped.
The oscillation
Undamped also. It is
will not
underdamped means
vanish.
no. Oscillation will vanish. You see here the first case. This is the case 1. Underdamped or undamped. There is another name for this also. Undamped also. Okay. This is another name for this.
Okay.
Undamped. So the case 1 is this one. Case 2. This is the red color is case 2, and this is case 3. Okay. So everything is depending upon the value of R, L, and C according to that. If there is no R in the system, it will always oscillate. That is another issue. Okay.
Yes.
But here you see here what will be the value of the current here. The current. The current initially will be 0, or what will be the current? IL of 0 minus was 0. So IL of 0 plus also will be 0.
Zero.
IL of t is nothing but your total current actually. What is the actual current? That is the I of t. So the current is starting from 0. So at first there will be oscillation. The current will be going like this, and after some time the current will go to 0, or you can say it is exponentially decaying like this. So this is I of t, or IC of t, not IC, yes, IC, everything is same, or IL of t. So at this point the current will be equal to I of t will be equal to 0, right?
Yes, sir.
Or capacitor is fully fully charged. Okay, sometimes you may get the response not without oscillation also. It will be going like this. It will be going like this kind of response. Sometimes you will get it. Okay, sometimes you will get the response in another way also, like this also you will get the response. So different kind of responses are possible according to the value of R, L and C. So if you change R, L and C, the responses also will change, okay. I hope this is clear to you, the logical explanation.
There are
Yes.
only 3 response: underdamping, overdamping.
Yeah, you will be more clear about it when I derive the equation, okay, inshallah.
Yes, sir.
So for deriving the equation, actually you need something known as you need to know some idea about the partial fraction. Do you have any idea on the partial fraction?
Yes, maybe, sir, maybe.
But to save the time, actually the purpose of the course is not to teach the partial fraction. So I will not give the complete step, but I will do one thing. I will give the how you can prove it, and finally I will write the answer, okay, without some intermediate step. I will skip some steps intermediate regarding the partial fraction, expansion and all this derivation, so that you will get a clear idea, inshallah. Okay.
Okay, sir.
So that is enough to understand. The other mathematics you can read at any time and you can understand it. That's not a big issue. So what I am going to do is I'm going to derive the response of the system. I can derive the response of the system in different ways by using differential equation. And I think I have sent a video in the electric circuit theory, our group, WhatsApp group, regarding the derivation. And it was by using differential equation. You can refer it it is the proof by using differential equation. But here, since it is a very beautiful explanation, that guy has beautifully explained it, so you can easily understand that concept. It doesn't matter. But here we will see how to derive it using Laplace transform. Okay, so we will use by using Laplace transform.
Okay,
the other
sir.
derivation, so both derivation will give you the same answer. Okay, so we are going to give a step input to the RLC circuit. Okay, so what I'm going to heading is step response of RLC network. So if you get this clear idea, if you understood the method of solving this, you can solve any RLC circuit by using the same technique. So R, you have a L and you have C, and some current is flowing through the circuit. You can say I of t, and you are giving a step input which is having V naught into U of t. This is the step input. So the step input is having a voltage V naught. It may be 10 volt, 20 volt, anything. Okay, any voltage.
The step input means that there is a switch open at t equals 0.
step input means you have a DC voltage and there is a switch, but the switch is closing at t equal to 0. So that is the meaning. Okay. Please refresh the concepts, okay, again and again, then otherwise you will forget. So what will be in the Laplace domain? What will be the R? R will be R itself, right?
Same.
But what will be L? SL, right? And this
SL.
become 1 by
1 by
SC.
SC.
Yes. Now I am going to find out the I of t for the input, how the current will be looking like if I know the voltage step for the input V naught into u of t. So what will be my Laplace transform of my current? Please, how will I represent it? Yes, I of t is having the Laplace transform I of s. I am using a double arrow. Why I am using a double arrow here?
That means you can change from time to main and opposite.
Yeah, you can.
Vice
Yes,
versa.
you can change in both. Yes, that's it. Okay, that you have to. So I of t, and what will be the Laplace transform of v naught into u of t? V naught is a constant, and u of t is having Laplace transform 1 by s. So v naught by s.
over s.
Yes, v naught over s. V naught over s. Now, what will be my z of s? Total impedance of the circuit. R plus SL plus 1 over S. Now how to find my I of S, my current I of S? Voltage
Divide
V of S
by Z.
Yes, this voltage is having a Laplace transform. I will just show here. This is my voltage. My voltage is having a Laplace transform V of S, and V of S is nothing but this is V of S. My voltage is having, this is my voltage V of t. My voltage is V of t is equal to V naught into U of t. It is having a Laplace transform V naught over S. So V of S, I will get V of S is equal to V naught over S, right? Now I am going to find the voltage divided by Z of S. That's my current, right? My current is voltage over,
Yes, sir.
yes, this divided by Z of S. So this is nothing but voltage over S divided by, what is Z of S? R plus SL plus 1
by CS.
1 by CS. Now you have no standard form like this. Now you have to find, now you got what is I of S. I of S is V naught over S by R plus SL plus 1 by SC. Now how to find I of t?
Partial fraction. Reverse Laplace transform.
Yes, we have to first take inverse Laplace transform of I of S. So inverse Laplace transform means I will just call it as inverse Laplace transform. So this is nothing but inverse Laplace transform. Okay, I have to go back. So I will use the next page. So I of S is nothing but V0 of S divided by, you can see here, nothing but R plus S what is it, SL plus 1 over SC. So this is the form, but I can write it in another way also. It's nothing but V naught over S divided by, I can cross multiply all this thing, so
Doctor,
it become
can we multiply S with the
SCR.
denominator?
I will tell you, this is like this is S square into LC, right, plus 1 divided by SC.
Yes.
Is it okay? So this is nothing
Yes,
but
can be so.
you have, Yes, it's V naught of S multiplied with SC divided by SCR plus S square
S
LC
will cancel S.
plus. Okay, so SS will cancel. So, and also I can take,
Excuse me, doctor.
yes,
From where you bring here SC in the denominator?
you see here,
You
what is
multiply
the A by
whole
B
denominator
over,
by SC, but why you divide also?
it's, see this formula, okay? I think it is clear to you. Okay, this is the
Yes,
basic
yes.
formula. Yes, that's
You
idea.
multiply and
So,
divide. Yes, yes. Same time. Yes, doctor. I got the point.
yes, yes. Okay. So this is the general formula. A by B over C by D is equal to A by B into D by C. Okay. This is the general fraction rule. Now you can see, I will, first of all, what I will do, I'm going to take this LC outside to have some rearrangements for the equation. LC outside, and I will write my S square plus, if I take LC from the second term, so that's, it's become C I take, it's
Divide
become
by
R
L.
over L, right? It's become R over L plus 1 over LC. Now you can see the CC will cancel, so it become V0 by L, okay? V0 by L, or I can say right like this. This become V0 by L, okay, into 1 over S square plus R by L into S plus 1 by LC. This is my I of S, right? Is it okay? I can write like
Yes,
this.
sir.
Why I am doing like this? Because I need a quadratic form. You know the quadratic form is ax square plus bx plus c, right?
Yes.
Yes, yes,
And
yes,
I
sir.
am
Yes.
making my coefficient. I am making my a equal to 1 here, right? I am going to make a equal to 1. So if I want to make this is equal to 0, means if I make a equal to 1, this become x square plus b by a into x plus c by a. This is equal to 0. You understood?
Yes, sir. Yes.
Yes. So I am
But here
going
is
to
the
write
problem here,
this.
doctor.
Yes.
Because here the function in the denominator, not like this.
Yes. Yes. What's the problem?
It's not same, doctor. Here it is in the denominator.
You see here, this is second degree, this is first degree, and this is 0 degree. Second, 1, 0. And we have also second degree, first degree, and 0 degree. That's what I'm saying. Okay.
Okay, doctor. Okay.
So I am going to write it in another way. V0 by L. Okay, I will use the next page. This is a derivation which is, it's V0 over L into 1 over S square plus R over L into S plus 1 over L. So I can, this is one, there is a one standard form in electrical engineering. Those who have studied the automatic control will be having this idea. I am going to write this in another form here, V0 by L S square plus 2 into alpha into S plus omega naught square.
Yes.
Okay, I am going to write in this form. If I compare these equations, just compare this, compare. Okay, if I compare this equation, what is 2 into alpha? 2
R
into
by
alpha
L.
is R by L. Okay, so that's it. So this is R by L. 2 into alpha is R by L. And what is my omega naught square? Is 1
Square
by
root
LC.
1 by LC.
1 by LC.
Or omega naught is equal to 1 by square root of LC. Okay, these are all my conditions now. Now I can write the above equation. I can write the above equation in a different way by using a method which is known as partial fraction. Actually, these are all mathematical steps. Don't worry about it. You will study in detail in automatic control. So by using partial fraction, you can write the above equation as I of s. You can write it like this: v0 over L is a constant, you know, into, you can see that this is a second degree equation. This equation is a second degree equation. So I am going to split into two first equation. There is some a over s p1 plus b over s plus p2. I can write like this. I have to find p1 and p2. That is another issue. Okay, you understood?
Yes, doctor. I have studied something like this
Yes.
before.
Yes. So anyway, this is a mathematical step. You can refer any max textbooks and you can get the idea. But I'm going to find it. If you know s plus p1, you will get solve this. If you solve this, I am not going to give the proof of this. If you solve this, you will get your a equal to minus b, and your a, you will get it as 1 by p2 minus p1, something like this. So you will get a formula like this. So you can solve this, and I'm going to write only the final equation. Okay, please leave all these other things.
Okay, sir.
I'm going to just write only the final equation. You will be getting the equation like this: I of t, sorry, the current will take this form: I of t is equal to v naught over,
I small.
you will get it as, sorry,
I small.
yes, v
I
naught,
small t, right?
oh sorry, I small t, because our current is small letter. Actually, usually in time domain we usually used to represent by using small letter. You will get it like this: alpha square minus omega naught square. And you should be very careful about what is alpha. Alpha is
R by L.
L by 2R.
yes, alpha equal to r by 2l. Okay, so you will get here alpha is equal to r by 2l, just I am writing here, and omega naught is equal to 1 by root of lc, let it be here. So you will get with an exponential 1 by e power minus alpha t, okay, into square root of, sorry, e power alpha t. Okay, I missed one point, please. I missed one point. This is a special option. So we are going to represent it by using the first option. My first option is that alpha square is greater than omega naught square. This is the first option. Why I am using this option? You know, the equation was like this.
R and L.
Yes, the equation was like this. This was my equation, right? This was my equation. If you take this,
Yes.
if you take this s square plus 2 into alpha into s plus omega naught square, what will be the root of this equation? What will be s? S is equal to, can you tell me? You know this thing, ax square plus bx plus c is equal to 0 means what is the root of this equation? Minus b plus or minus, what is x? X is equal to minus b plus or minus?
The general form.
Yes, root of b square minus 4ac by 2a.
Yes.
Yes, I think you know all these things. Abdulaziz,
Yes.
Yes.
you have yes. So I am
Yes,
using
yes,
this
sir.
form to find my s. Okay, I am going to find the root of the equation. I am going to find the root of this guy. Just finding the root of this guy. This root is having some special significance. You understood, Ryan? this root is having
Yes,
special
doctor.
significance. According to the nature of this root, the response will change. That means according to this root,
Right.
according to the nature of the root, the response will change. I told you sometimes you will get oscillation, damped oscillation. Sometimes you will not get oscillation. Sometimes you will get the hyperbolic response. I told you, right? It will be depending
Yes,
upon the
yes.
root of this equation. Okay, it is
The
noticed
root here
that it
can
is
be
based on the root.
just two cases, doctor. Am I right?
There are 3 cases. Inshallah, we will see how many
But the
cases are there.
value,
So
the
we are
value, the
first
solution of this equation.
we are first discussing. We are first taking the case 1 now. Okay, inshallah, we will see. According
Yes,
to
doctor.
the root,
Doctor,
yes,
here the equation
yes.
has two solutions. That's mean only we have two cases. Am I right?
No, it doesn't mean like that. We will see. There
Okay,
are
sir.
2. How many S we will get here? How many roots will be there?
You get two solutions.
Because it is second order. That's why you will get 2S, right?
Yes.
But this solution will change according to the value of alpha and omega. Do you agree with me?
Yes.
That we will
You're
see.
right, doctor.
So we will see our roots will be like this. Minus b. What is minus b? Minus 2 alpha, right? Plus or minus square root of b square. B square means what? How much?
4 alpha square.
4 alpha.
4 alpha square, right? B square
Yes.
minus 4 into a c. A is 1 and c is omega
Minus 1,
naught
yes.
square, right?
Omega square.
Yes, divided by
Yes.
2a. 2a means 2 into 1.
2.
So my S will be equal to, you can see here, minus alpha plus or minus. This is root of 4 is there. You can take it outside. So 2 will cancel. So the root will be alpha square minus omega naught square. Is it clear? This will be my root.
Yes,
Okay.
right.
So we
Yes.
will discuss here the root of the
Yes, doctor.
denominator. Okay, denominator. And this denominator is having a special name. There is a special name in electrical engineering for this kind of denominator, which is known as characteristic equation. Characteristic equation. Why this name? Can you tell me? Characteristic equation. Character. You know character.
Because I think we can find the specification of signal by the denominator.
Yes, because this root, the root of this denominator we will call characteristic equation, and the root of the denominator will give you the nature of the response. How the response will look like will depend upon the root of the denominator. You understood? And the root
Yes,
is
yes.
nothing but this one. Okay, so the root will give you the character of the system. The character of the system will depend upon the root of this equation. That's why it is known as characteristic equation. And the root we will call another. The root is having another name also. It is having another name in electrical engineering, also in automatic control. It is known as pole. Have you heard about this?
Yes.
So the root of this characteristic equation means CE. The root of this equation, that means the root of the characteristic equation is known as the pole of the system. So according to the nature of the pole, you will get different response. So I write the pole of the system now. My root I am going to write, or I will say pole of the system. Poles. There are 2 poles here. How many roots are there? 2 roots, right? So how many poles are there? 2 poles. So it's nothing but the root of this equation. My roots are S is equal to minus alpha. I have a plus or minus. That means first root means S1 is the first root plus root of, what is that? Alpha square minus omega naught square. You understood?
Okay.
Yes,
And
sir.
S2, yes, minus alpha minus root of alpha square minus omega naught square. So that's it. Now we will see how this guy, I will give you first a physical explanation. After that, I will prove mathematically. Okay, I will give you a very good physical explanation before proceeding the mathematical things. What are the choices of this root? What will happen? First of all, case 1, if alpha is equal to omega naught, what will happen?
No damping.
What will be the root of the system? S1 is equal to
minus alpha.
alpha. S2
Minus
also will be
Minus
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 alpha.
alpha.
Am I correct?
minus alpha also.
Yes. So both roots are at the same position. I can represent like this.
Real,
S is a
they are real.
I can represent like this. S is a complex number, and S is a complex number. This is S plane. I am saying S
There is
plane.
mistake,
It's a
doctor.
complex
Excuse
plane.
Doctor, why is
Yes.
the square equal the
Oh, sorry,
omega
not
naught
square. Okay, S. Okay, sorry. Alpha is equal to omega naught. Okay, sorry. That's my writing mistake
No,
actually.
it's okay.
Okay, and you know this sigma plus j omega. So this is my sigma axis and this is my j omega axis. Now both roots are which position? Which position? At minus alpha. Positive side or negative side?
Left
This is
side.
positive sigma
Left
and
side.
this is negative sigma. Which
Negative
side? Please tell me.
Negative.
It's
Left,
negative
doctor.
side, and we will say this two poles, and two poles are whether it is real number or complex number. Alpha.
Real.
it is
I
real,
told you
doctor.
about
Real.
alpha. Yes, alpha is r by 2l. You know this thing. Alpha is r by 2l. R by 2l. It's a real number. Okay, and you have two real numbers on side, and both are at the same position. Okay, so both roots
Yes.
are at the same position, and this is minus alpha. Okay,
Yes,
I got
doctor.
it. I think you got it. Yes. So then this kind of system, you cannot see any oscillation. What is the factor regarding omega? Can you tell any factor regarding omega? Any imaginary number is there in the root?
No.
No.
Yes. If you cannot see any imaginary number in the root, it will be purely like this. It will be going like this and with an doubly exponential. You can see there are two roots at the same position. You understood?
Yes.
Yes, sir.
So it will be, yeah, it will take a characteristics which damping. You can see it is a damped system. More damping is there. That's why it cannot oscillate. It is having high damping, so it cannot oscillate because only real roots are there. That means the poles are
Real.
okay. So no oscillation. The observation is that no oscillation. Inshallah, we will come to that later. And another case, inshallah, case 2. These are all very, very important concept that I am saying. You have to read some 5 or 6 books to get all these things. That's why please focus or please listen very carefully. Now, what was my root? S is equal to minus alpha plus or minus
Square
root
root
of
alpha square
alpha square
minus
minus
omega square.
omega naught square. And what was my alpha? Alpha was actually, I don't remember all these formulas. That's why I am r by 2l, r by 2l. And what is my omega naught? Is 1 by root LC, right? Now, another case I am talking about, if my alpha is greater than omega naught, what will be the situation?
It's gonna be real number, sir.
Yes. So before that, I told you these roots are at the same position. In case number 1, our roots are at the same position, and our roots were in like this. Our system was like this, in this format: S by P, S plus P1 and B by S plus P1. This is the rough thing I can say about the system. V naught by L is also there. So you can see both are having the same number, right? The roots are same. P1 is equal to P2.
Yes.
P1 will be equal to P2 because both are having minus alpha. Am I correct?
Yes, sir.
Yes, sir.
So if both roots are same, you will get, what will be the response? Please tell me.
No damping.
Damping, sure, there will be damping.
Over damping. Over damping.
If the roots are same, doctor.
Yes, if the roots are same, what will be the situation? If roots are same, we will see that. Okay.
Over damping, sir.
So if roots are same, what will be the situation? If both are equal, then the situation will be different. It's an overdamped system anyway. It is an overdamped system. It's we cannot say it is an overdamped. Actually, it is a both poles are same means it's a critically damped system. It's a critically damped system anyway. Inshallah, that you will study in more detail in automatic control. Okay, I'm not going to discuss that. Inshallah,
We have studied
but
this
please
before,
understand.
doctor.
Automatic control you have already finished.
No, we have studied this in circuit too.
Ah, okay. So no, you will study more detail in automatic control regarding the pole zero. This is the explanation regarding the pole of the system. But you understand that here the roots are real, so there will not be oscillation. Okay, there will not be any oscillation. Okay.
Yes, sir.
Yes, doctor.
Now we will see what will be the
Okay.
situation if alpha is greater than omega naught. If alpha is greater than omega naught, you will be having some number here, right? So then
Yes.
you can say, yes, then you can say there is a number here, square root of alpha square minus omega naught. If alpha is greater than omega, this will be greater than 0, right? This
Right.
number inside,
Yes.
it will be greater than 0. So the root,
Yes, sir.
that means that alpha square minus omega naught square will be greater than 0. That means the root will be what, real or imaginary? If it is greater than 0,
Real.
the root will be,
Gonna be real, sir.
it will,
Real.
yes, the roots are real, and you will get two roots. S1 is equal to minus alpha plus,
Minus alpha
let's say
plus the root.
this is beta. Let us assume that this is beta. So this term I'm saying this is beta, square root of, so minus alpha plus beta, and you will get minus alpha minus beta. Am I correct?
Yes, sir.
Yes, sir.
Yes.
So what will be the location of the pole? This is sigma, this is j omega. So you will get one pole here, minus alpha plus beta, which is more close to 0, and this guy will be minus alpha minus beta. So you will get another pole here. You understood?
Yes, sir.
Yes, right.
Yes. This kind of system will be actually, it will be, we can say it is an overdamped system. It is an overdamped system. As I told you, there is no omega term in this, so no oscillation, right? There
Yes,
will be no
sir.
oscillation. And that means this system will be having the damping factor. You can easily find the damping factor of this system will be, overdamped means greater than 1. And what will be the damping factor of the previous system? Both roots are at the same position. That means the damping factor will be critically damped. We will call it as critically damped. I hope this is clear to you. This idea is clear to you. Logical explanation is clear to you. Okay, critical. So
Clear, Doctor.
yes, how the response will be looking like? The response will be looking like the voltage, suppose charging, you can see this will be critically damped system. That means delta equal to 1, and over damped system means it's slow response, very slow. Delta greater than 1. It's the time. This is Vc of t. There is no oscillation here. Am I correct?
Yes.
Yes. This kind of response you can see in this kind of system. And actually I missed one point. It was there in my mind, actually I forgot. Inshallah, when it comes to my mind, I will explain. Okay. Yes. Now you can see here the response of the system is, this is our case 1. Case 1, that means both roots are at the same position. And this is our case 2. Yes, this was case 2. My both roots, one root is here and one root is here. Am I correct? Yes. Now you see,
Yes.
there is one very, very important idea. Yes, this is what I want to explain. There is one important idea. Whatever this sigma, this is sigma, and this is j omega, this number actually minus alpha
Doctor,
plus beta and
Doctor,
minus alpha minus beta. Yes.
I think you forgot something. From previous equation, when you put V naught by L and the denominator S square, the quadratic form.
It is having quadratic. I didn't actually, I didn't write it here anything. You see here, I
Yes, it
didn't write
has
it
to be
here. It is,
S square. It has to
yes,
be
which
S
one?
square plus 2 alpha omega n S
Which one
plus
you are saying?
omega naught square.
Which one you are saying?
Before
This one?
back once.
Yes, this is I have. I think there is no error here.
I think
Okay.
we took it like S square plus 2 alpha or 2
Yes.
zeta omega naught S
No, no, no,
plus
no, no, no,
omega
no,
naught
no, no,
square.
no, 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 no. That you have studied control system. Know that thing. Okay, that is different. This is that is in the form S square plus 2 into
Oh,
zeta into omega n into S plus omega n square. You are talking
yes,
about this
yes,
form, right? Am I correct?
yes,
This form you are talking about.
yes, yes.
Okay, but we are actually, since many students didn't study the automatic control, I am just talking about the general solution. Okay, that's why. Okay, please don't just forget about the other things.
So this is
Okay.
different, Doctor, right?
Actually, I am finding the root of the system. That's it. Okay, nothing else. You forget about the control
Okay,
system.
okay, good.
I am just finding the root of the quadratic equation and
Okay.
how it will be looking like. Now I told you this was our case 2 and this was our case 1. In case 1 is 2 time constant. Am I correct? Sorry, not time constant, 2 roots at the same position. Okay.
Yes.
Now,
Okay.
Yes, Doctor.
yes, there is an important concept. Don't forget this one. If there is a pole which is real, a real pole actually gives you an idea about the time
Doctor, are you
constant of the
writing
system.
something now?
Oh, it's not coming. What happened? I don't know. Just wait, okay. Maybe due to some connection issue.
Okay, no problem.
So, what is happening here? Just wait, I will just close this one and open again, okay? 1 second.
Okay,
Wait,
Okay.
wait. Now, can you see now, right?
Yes,
Yes.
doctor.
Yes. Now, please listen carefully. This is very, very important concept I am saying. How the roots of this polynomial will be giving you an idea about the time constant of the system. It will give you an idea about the time constant of the system. Can you tell me what is the general form of exponential decay? Exponential decay is having e power minus, what is the general form? T or tau.
e power minus t by
Or exponential rise, that means this is the exponential decay, and exponential rise is having, what is the form? Like this, right? It is having a form 1
Yes,
minus
sir.
e power minus t
positive,
over
not
tau.
negative.
Yes, I think this is clear to you, this idea, both.
Okay.
Now I told you how many roots are there? How many roots are there? I am talking about case 1 here. This is case 1 I am talking about.
2 roots.
Case 2.
2.
Yes, 2 roots. There are 2 roots or 2 poles. 2 poles, and both poles are at same location, right? Same poles, both are at same. So, and both poles are real poles. So real poles means it is actually the time constant of the system. You can easily prove it mathematically. It is nothing but the time constant of the system. So time constant of the system. So how many time constants are here? You can see one root is
1.
yes, one is one time constant. One pole is giving you one time constant, tau 1. Another will give you another time constant, tau 2. But in our case,
But they are
both
same.
tau 1, both are same. So both will work together. Both will be same. That means it will, suppose if it is going high, it will go high in the same way. If both are going down, it will be
Yes,
going
yes.
down in the same way, right?
Yes, sir.
If
Okay.
both of them do like that, then the system will be having a damping. I told you the system will respond like this.
Critically damped.
Respond like this. Critically damped. That means you can say delta equal to 1. Both will be together, right? There is no issue. But here you see here, the first case 2 now. I'm talking
Doctor,
about case
excuse
2.
me.
Yes.
What do you mean by critically damped?
The critically damped means there is a general form for this equation which is known as which is the common form which is used in control system. So based on that response, actually we can classify the system into 3 types. First type is delta equal to 1, another type delta greater than 1, and another type is delta less than 1. Based on this response, I told you if you have this response, you have get oscillation. In the oscillation means you have delta less than 1. And if you have something like this, we will call delta equal to 1. And if it is very slow, we will say delta is greater than 1. And this delta can be defined by using some other term. Inshallah, I will define it. Inshallah, what is delta? Okay? Don't worry.
Okay, sir.
You know that, okay, I will use this page itself for explaining delta. S square plus 2 into alpha into S plus omega naught square. Omega naught square. Okay. So this is our equation, right? In automatic control, inshallah, you will see. I'm not going to prove it. A lot of things are required to prove it. You will see the general form S square plus 2 into delta into omega n S plus omega n square. Now, can you tell me what is my, if you compare this equation, 2 into alpha will be equal to 2 into delta into omega n, or omega naught, you can say omega naught. Omega naught. Is it okay? My comparison. So what will be
Yes,
my
yes,
delta?
sir.
My delta will be equal to, the 2 will cancel. My delta will be equal to alpha by
Alpha by
omega
omega
naught.
naught.
Yo, this is my equation for delta. Delta equal to alpha by omega naught. I hope it is clear to you, both Majid also. Majid, I think now his confusion is over, right? Majid?
He's not here,
Is there?
Doctor.
Oh, okay. So I hope this is clear to you. So delta
Clear,
is a
Doctor.
factor. So you can see here, if I will tell you what is this. So what is the equation for delta now? Delta equal to, please remember this equation. I will ask you, delta is equal to alpha by omega naught, right?
Yes, Doctor.
Okay.
So in case one, we have already discussed. In case one, we have discussed what is this? Alpha equal to omega naught, right? Case one is alpha equal to omega naught. If alpha equal to omega naught
Yes.
in case one, if alpha equal to omega naught, then what will be delta in this case?
It's gonna be 1 or so.
It will be 1 because delta is defined by alpha by omega naught. I told you just now. That's the meaning.
Yes.
You understood? That's the meaning. And what is
Yes,
alpha?
sir.
You know, alpha is a function of R and L. Alpha is a function of R and L. And omega naught is a function of L and C. That's why I told you the response of the system will depend upon the value of R, L, and C, everything. You understood? So you can see both
Yes,
this
sir.
system is critically damped. Why it is critically damped? It is because both the poles are at the same location. So if both are at same location, the meaning is critically damped. Critically damped. That means delta equal to 1. Now we will see our, I will just avoid this page, that's better. Otherwise, for this case 1, this is just for case 1. So critically damped system, delta equal to 1 means critically damped. Okay, is it interesting? This topic is interesting to you? That's what I want to know. Otherwise, there is no point.
Of course, sir.
Yes, this is very, very critical thing. If you understand it very carefully, all other subjects like if you are talking about the oscillator, if you are talking about the automatic control, everything become very easy if you understand this thing very beautifully. So if delta equal to 1, then S1 will be is the first pole and S2 it will be the second pole. Both will be same, or you can
Minus
say tau 1 is equal to tau 2, time constant. I am saying both constant. That means time constant due to R and L and C, or you can say in another time, in another way you can say both time constant. That's it. Okay, both time constant will be same. That means the system will respond not too fast, not too slow. That's the meaning. You understood? The meaning is the system will respond not very fast, not very slow, because
between them.
it is critical. Yes, it is critically damped. Delta equal to 1. That's it. Next, we will see what is case 2. Case 2 we will
Doctor,
see. Yes.
can you please remove this tab?
Oh, something coming. Okay, sorry. So case 2. Case 2 was having two roots. One is equal to minus of alpha plus square root of alpha minus omega naught square, and we have alpha square minus omega naught square. We have already given that alpha is greater than omega naught, right? This was our case 2. And S2
Yes,
is equal to minus
Yes.
alpha minus alpha square minus omega naught square, and both conditions, and all the roots are real. All are real, both are real, right? So roots are real, I told you. So one is like this, minus alpha plus beta. I told you what is beta. Beta is nothing but square root of alpha square minus omega naught square. And another root is like this, minus alpha minus beta. So which number is more negative? This you can say this is tau 1,
Yes, alpha
and
minus.
this you
it's
can
2.
tau 2.
Tau
Yes,
1.
there are two time constant. One is time constant. That means if you take the time constant tau 1 is having more magnitude, you can say. It's negative means what? It is going down. That is having
Yes.
more value than tau 2. If there are two time constant in a system, which one will dominate?
The higher one.
Higher one.
What do you mean by dominate, sir?
Suppose you have, if you have one time constant tau 1, let's say you have a time constant, let's say t1 time constant. What will be the response? The response will be like this, e power minus t over t1. Understood? Now if you have t2,
Okay.
if t2 is very high, then what will be the response? Whether it will be slow or fast?
It will take more time to decay.
Yes,
It will
be
take
slow,
more
very
time.
slow.
It will take
Yes,
more time.
The less one, it will be dominate.
Yes. So what will be the response of the total system now? This is e power minus t over.
Overdamped.
You can say, just forget about overdamped and underdamped and all. So this system T2 is greater than T1. Am I correct? T2 is greater than T1. I am talking about this case.
Yes.
Yes. So what about this is a general example. Okay. General example. So if both are there, the system contains, which one will dominate? That's what I'm asking. Dominate means which response will be last long?
Who has the less magnitude?
One has the less magnitude, right? One has the less magnitude, right?
Yes.
Am I correct? Why nobody is responding?
Yes,
I don't know.
Yes.
Yes, it's
Let me check. Okay, let me check first. So first of all, you have a time constant. Let's say t1 is equal to 2 seconds. Okay, and t2 equal to 4 seconds. So the system will come to steady state. I told you steady state is how many? 5 times time constant. So it will go in 10 seconds. This will come to 0. This guy. What about this one? What about this one?
It will take longer time, sir.
Yes, it will take how much? 5 into 4,
seconds.
right? 20 seconds. Now can you tell me which time constant will dominate here?
I think who has the less magnitude.
Dominate
because
means
change faster.
no, you see here the part will go to 0 immediately. The first part will go to 0 immediately. The second part will go to 0 after 20 seconds. This is having 10 seconds and this is having 20 seconds. So which response will you see after 15 seconds? After, just observe the system after 15 seconds. Who will be there?
the second
T2.
one.
Yes, second one will be there. First one is already finished. He has no role. So who is dominating? Who is having authority now? Second or first?
The second one.
Yes. So if T2 is greater than T1, then the dominant one is T2, right? Am I correct?
Yes. Right.
Yes. So which is having more time constant, that is dominating. But there is a relation between the pole and time constant. I will tell you the relation between the pole and the time constant is nothing but the magnitude of the pole will be equal to magnitude of 1 over tau. You understood? There is a relationship. Inshallah, you will study in automatic control. So which So if the magnitude of, that means if T2 is greater than T1, the magnitude of P2 will be less than magnitude of P1, where P1 and P2, Pi means pole. It's nothing but the pole of the system. Pole of the system. So can you tell me now, here T2 is, which magnitude is now greater, T2 or T1? T1 is greater than
T2 greater, doctor.
Sorry, this notation is having, I am talking about the
I
poles.
think it's
This is
the
P1.
opposite, right?
This is, yes, it's P1 and P2, two poles. Which magnitude is greater, P2 or P1?
B1, sir.
Yes, magnitude of P1 is greater than magnitude of P2. So the magnitude of tau 1 is less than magnitude of tau 2. Am I correct?
Yes, sir.
Because it is having inverse relation, because Pi, magnitude of Pi is nothing but the magnitude of 1 by tau. That's it, just inverse. So which one will dominate here according to our condition, T2 or T1? Which one will dominate?
Doctor, what's the meaning
I told
of
you.
dominate?
T2.
Dominate. Yes, T2 will dominate. So T2 dominate means which pole will dominate? Which pole? This is the pole,
Doctor,
actually.
excuse me.
Yes, excuse me, I will just come to that point, inshallah. Okay, so which pole will dominate? P2 will dominate, right? I told you T2 will dominate. So which one will dominate? The pole P2 will dominate, and we will call this pole as dominant pole. That is the meaning, dominant pole. Inshallah, I will explain once again, don't worry. Okay.
Doctor.
Inshallah, even though if we take more time, there is no issue. Inshallah, we will continue next week.
I don't understand what you mean, doctor, by dominate. Dominate boy. What's
Dominate means, did you understand this case? T1 equal to 2 seconds.
Yes,
T1
sir.
equal to 2 seconds. And T2 equal to 4 seconds.
Yes, sir.
Now, if a system contains T1 and T2, both are there, then if you see the response of the system after 10 seconds, you see here the steady state is 10 seconds, and here the steady state is 20 seconds. Am I correct? Because steady state means 5 times time
after 5 times. Yes.
Yes. Now you see the system not before 10 seconds, you just see the system after 10 seconds. Let us take an example. You see the system. Your system contains both. Your system contains T1 and T2. You see, and T1 is 2 seconds and T2 is 4 seconds. Now you observe the system after 15 seconds. You know the steady state for this is 10 seconds, and this one is 20 seconds.
20 seconds.
Now observe the system after 15 seconds, just at 15th second, at 15th second. Which response you will see?
You see T2, sir.
Yes, T1 is already died, right? It is already died.
Yes, finished.
Is finished. So which is having more authority now, T2 or T1?
T2, sir.
Yes, so something which is having more authority, we will call it is dominating. It is dominating over T2. T1, it is dominating. T2 is dominating over T1. That means we will call our T2 is dominating. You understood?
Yes, sir.
So what will be the pole for this? P2 will be equal to 1 over
1
T2.
by T2.
You understood? So this
Yes, sir.
pole, we will call this pole as dominating pole. Dominating pole. You understood?
Understood, sir.
Since T2 is big number, 1 by T2 will be a small number. Do you agree with me? If T2 is a big
Of
number,
course.
yes, yes. So I am talking about the magnitude. So now you can see, the magnitude is this much, and the second pole is having another pole. Second pole is having magnitude this much, and another pole is having magnitude this much. So which pole is having magnitude very small number, P1 or P2?
B2, sir.
Yes.
P2.
Since so, which time constant will be dominating, T2 or T1?
T2, sir.
T2.
T2.
That's why we will call this guy as dominating pole. So what is the meaning of dominating pole? Dominating pole is the pole which is close to 0. This is your 0, right? This is your 0. Am I correct?
Yes, sir.
Yes.
So the pole which is very close to 0 will dominate always. Is it clear? The pole which is very close to 0 will always dominate.
Got the point, sir.
Okay.
Yes, I think that is clear to you. So the response of the system will be due to the root of the characteristic equation which is very close to 0. You can see a response which is very close to 0. That's why you can see the response of the system because of the root which is close to 0. Other will not show that much. Understood? So that's what I am saying to you.
Yes,
Now
sir.
we will see one more case 3.
The third case.
Yes, case 3, or let me continue tomorrow, or it's okay for you?
As you like, sir.
I think that is better. I think you may be saturated, but please, you have to read this before coming to tomorrow's lecture, okay? Otherwise, you will not understand anything.
Inshallah, sir.
Inshallah, okay? Abdullah,
Yes,
what
doctor.
has happened to them? Okay, please read this carefully. This is very, very beautiful concept and very, very important
Yes.
thing. So before coming to tomorrow's, please read this lecture very carefully. So when the roots of the polynomial characteristic equations both are at the same position, you will get critically damped. If both are different, you will get overdamped. And what is the reason for this overdamping? The overdamping is because of the pole which is dominating and which is just close to 0. You understood? The overdamping is because of the overdamping is because of the pole which is very close to 0. Pole means root of the equation. So there are two roots. One root is very close to 0, and that guy will make the system overdamp. That means that will not prevent the system to go fast. It will always have high time constant. So it will respond very, 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 very slowly. You understood? That's the meaning.
Yes, sir.
Inshallah, we will continue our discussion because we have lot of cases. Till now, we just discussed only the cases with real roots, right?
Yes, sir.
Yes.
Now we have other kind of combination also. What are other kind of combination? Now we have
Real and
discussed the real
imaginary.
root.
Number.
Now next with real plus j times imaginary number, right? Or real and imaginary.
Yes.
Yes, sir.
Another with only imaginary, right?
Yes.
Can you I will explain tomorrow anyway. If
Cannot
there is
be,
real
sir.
and imaginary, there is something which sometimes comes only imaginary also. If alpha equal to 0, what is alpha? R by 2L.
Oh, yes. Can be.
If your resistance, if resistor becomes 0, alpha becomes 0, right?
Right.
You are right, sir.
Then the root will be pure imaginary, right? There will be two roots. One root will be positive j omega naught, and you will get j omega minus j omega naught. If roots are like this, there is no resistor, that means there is no damping. The response will be sinusoidal, pure oscillation. You understood?
Yes, sir. Yes.
Yes. Yes.
But another case is there. Just I told you, if there is another case, the first case, that means real and imaginary. If there is a real number here and imaginary number here, the roots will be both. There is a real minus alpha here. Both are having same real part, but imaginary part will be j omega naught and minus j omega naught. This will be the case. So you have omega naught. So there will be oscillation. Am I correct?
Sure, sir.
Yes.
But there is a time constant. What will happen if there is a time constant? The oscillation will,
Damping.
yes, decay. So you will get a decayed oscillation. You understood? This is the idea of the roots. You
Yes,
understood?
sir.
Inshallah,
Yes.
that we will explain tomorrow, inshallah. Okay, don't worry, we will explain
Inshallah,
tomorrow. This
sure.
is not required. Okay,
Inshallah,
I
inshallah.
hope this is the you got the beauty of this concept. I think so, right?
Inshallah, inshallah.
How the roots of the system. That is why, according to the nature of the roots, the character of the system will change. That's why we are calling the denominator as the characteristic equation. Okay, inshallah, we will come to that tomorrow.
Yes,
Okay,
sir.
assalamu alaikum.
Walaikum salam. Thank you, sir.
عليكم
Thank you.
السلام ورحمة الله.
Thank you for your time.